Alright, in this video here we're going to talk about the graphs of the secant and cosecant functions. And to get those graphs, I'm going to compare them to the graphs of the sine and cosine functions and use the reciprocal properties to see what the graphs of secant and cosecant are going to look like. Alright, so what I drew up here first is the graph of the sine function, right? Y equals sine of x, which goes through the origin 0, 0, has a period of 2 pi, so I drew 2 full periods of the graph here. Right, and it goes from that middle point at 0 up to the high point at 1, back down to 0, down to the low point at -1, and then back to 0 to complete one full period. All right, now, if you recall, the cosecant function is the reciprocal of the sine function. Right, so cosecant of x is equal to 1 over sine of x. All right, so that's the reciprocal relationship between those functions, which I've talked about in other videos that I've done. All right, so cosecant and sine are reciprocals of each other. Right, so since they're reciprocals of each other, since they're just like kind of flipping over, well, to graph the cosecant function, kind of what I do is like flip over the graph of the sine function, sort of, not exactly, but it kind of has that feel to it as far as what we do. All right, so first off, the cosecant function is going to have some vertical asymptotes. Right, if you recall from what we talked about when I did that video on rational functions a while back, and if you haven't seen that, you might want to check it out to get the description of vertical asymptotes. But when you have a function that's a fraction, and the cosecant function is a fraction, it's 1 over sine of x, wherever that denominator equals 0, this function is going to have, or this graph is going to have vertical asymptotes, because I'm not allowed to have 0 in the denominator of a fraction. All right, so if I look at the graph of the sine function, everywhere the sine function equals 0, meaning anytime that sine function touches the x-axis, the cosecant function is going to have vertical asymptotes. So the cosecant function is going to have a vertical asymptote along the y-axis here, right? Because that's where sine equals 0, that point right there. Over here at negative pi, vertical asymptote, negative 2 pi, vertical asymptote, pi over here, vertical asymptote, 2 pi, another vertical asymptote. Right, so at all the multiples of pi, right, 0, 1 pi, 2 pi, 3 pi, -1 pi, -2 pi, that's where our cosecant function has its vertical asymptotes. Right, wherever the sine function equals 0, cosecant, since it's the reciprocal, well, I can't have 1 over 0. Right, that's not allowed. Right, that's undefined mathematically, having 0 in the denominator. So everywhere sine equals 0, I can just, on the graph, draw those vertical asymptotes. All right, and then the cosecant function is the reciprocal of the sine function, which means flipping it over. So then what I do is basically I go to each interval here between these vertical asymptotes, and I just flip the graph of sine over. Right. So here between -2 pi and negative pi, my sine function is going like that. I flip it over and have it go this way. In between those asymptotes, that's my graph of that section of the cosecant function. Right. Over here between negative pi and 0. My sine function is right there. I flip that over, and there's my graph of the cosecant function in that interval. All right, the one up here, I flip this one over, and so I get that graph there, and then over here I flip this one over, and so the graph up here in black, that's the graph of the cosecant function. Right, so the pieces of the cosecant graph, they look a little bit like parabolas. They are not parabolas, because remember, a parabola for a quadratic function, it has that U shape, but it keeps spreading out in both directions forever. Right? It doesn't just go straight up and down. Right? These ones, since they're in between those vertical asymptotes, they don't spread out forever. This one has like pretty steep walls to it, almost like vertical sides as you get down there, because it keeps getting closer to those vertical asymptotes without ever actually touching them. Right? So they're not exactly parabolas, but they look a little bit like parabolas. Right, they just have steeper sides because they're trapped within those asymptotes. Right, so that's how you can get the graph of the cosecant function from the sine function. Just remembering that cosecant and sine are not inverses; they're reciprocals of each other. Right, so everywhere sine is equal to 0, everywhere the sine graph touches the x-axis, you draw the vertical asymptotes, and then in between the asymptotes, you just flip over each section of the graph, and you get this weird, disconnected series of U-shapes. That's your graph of the cosecant function. Right? So that's what cosecant looks like. That's an easy way to figure it out. Now, I'm going to pause this in a minute and erase all this and put up the graph of the secant function, and that one's going to come from the cosine graph, because secant and cosine are reciprocals of each other. So the graph of the secant function is going to look kind of similar to this one here, except those U shapes are going to be slightly offset. They're going to be in different places because the sine and cosine graphs, even though they're both those waves, they have different starting points, and so they're like offset a little bit from each other. So it's like the secant graph and the cosecant graph look very similar, and if you just look at one of them, you're not told which function it is. Sometimes it's hard to tell which one is which, because the secant graph is also going to have these U shapes on the top and the bottom. They're just going to be in different spots, right? So the way to tell which one is which is by thinking about the reciprocal function, right? Cosecant and sine are reciprocals, so wherever sine equals 0, that tells you where you get those vertical asymptotes for the cosecant function. The secant function is going to have vertical asymptotes in different spots. All right, so I'm going to pause this now, erase this one, and put up the graph of the cosine function, and we'll use that to figure out what the graph of secant looks like. All right, so I put up here on the board now in red the graph of y equals cosine of x. And if you didn't watch the videos that I did on the graphs of the sine and cosine functions, I did one video on each of those, so you might want to check those out so you understand where these graphs come from. But these are graphs that you should know. Like going forward, you should know when I say the graph y equals cosine x, you should be able to picture that this is what that graph looks like. Right? So y equals cosine x, at x equals 0, it's up here at 1, and then it goes down to the middle, down to -1, back to the middle, back up to the top to complete the period. Just like the sine function, the period of the cosine graph is 2 pi, right? So I drew up here 2 full periods between -2 pi and +2 pi. All right, so that's 2 full periods of the graph of the cosine function. All right, now if I want to graph the secant function, right, we recall that secant of x is the reciprocal of cosine of x, right? Secant of x equals 1 over cosine of x. All right, so just like what we did a few minutes ago with the sine function and the cosecant function, we're going to do the same thing here with the cosine and the secant. Right, so since it's a fraction, wherever that cosine x is equal to 0, that's when I'm going to have vertical asymptotes. Right, so everywhere this graph of the cosine function crosses that x-axis, I'm just going to go ahead and draw a vertical asymptote through that point. Right, and notice from the one that was up here a few minutes ago, I have different vertical asymptotes. Right, because my cosine graph crosses the x-axis in different places than my sine graph did, right? So, the cosecant and the secant graphs have those vertical asymptotes in different places, right? They both have the vertical asymptotes, but they're not in the same spot, right? So it's the one thing to be aware of. The difference between these two functions is where those vertical asymptotes are, right? And then once you do that, we're going to do the same thing we did last time, right? Since secant is the reciprocal of cosine, it's just flipping it over. I just take my graph of cosine in between those asymptotes, and I just flip each one over. Right, now at this point, I don't think I mentioned this when I talked about the sine and the cosecant, but this point right here, like that low point on the graph of the cosine function, the secant function shares that point. So those do intersect at that one point. Right, this point here, they're going to intersect. At this point, they intersect. Right, so they share that point. The same thing happens with the cosecant and the sine graphs. Wherever you flip those things over, that point where they meet, they do actually meet there, and they do actually share that point. Right. So in between these asymptotes, I flip over this one up here. So it's going to go up between those. This one's going to come down over here. This one's going to be up over here. There's going to be the other side to it over there, which I didn't have enough space to do. Right. So up here in black now we have the graph of the secant function. Right, which again, it looks a lot like the cosecant function that we had up here a few minutes ago. I mean, it has the same, like there's something like this, and then something like that, and then this, and then that, and it just keeps repeating that over and over again. The difference is where they are, right? Those vertical asymptotes, like I just said, are in different spots, and so that's the difference between the graph of secant and cosecant. And to figure out where they are, just remember which one is the reciprocal of which, right? Secant and cosine are reciprocals, so wherever cosine equals 0, that's where secant's going to have those vertical asymptotes. And cosecant and sine are reciprocal, so wherever sine equals 0, that's where cosecant gets the vertical asymptotes. Otherwise, these graphs are very similar to each other, right? Just like the sine and cosine graphs, the periods for secant and cosecant are both 2 pi, right? You might think, well, in between here and here, that's one full thing, but the full period is that upper U shape and also the lower U shape. So between -pi/2 and 3 pi/2, that's one full period of the secant graph, right? The upper part and the lower part together makes one full period. And then once you have an upper and a lower, then you move over, and for the next 2 pi period, you have another upper and another lower, right? So you need both of those, the top part and the bottom part, to complete a full period, right? So that's our periods of sine, secant and cosecant. They're the same as the periods of sine and cosine because they're reciprocals of them. They share the periods. All right, so that's how you can graph secant and cosecant functions, and you can use the rules for transformations of functions to do transformations of graphs of secant and cosecant. I'm not going to spend a lot of time on that, or actually no time on that at all, because that kind of stuff doesn't really come up that often. But if you do have to do that, you might want to check out the videos that I've done on the transformations of graphs of sine and cosine. The same rules apply. You're just transforming these shapes here instead of the red graph that's in the middle. But it kind of works the same way, right? It follows those same rules. All right, so those are our graphs of our last two trig functions, secant and cosecant.